Now let us see some interesting fact about subspace. To know whether a subset is a vector space or not, it is enough to check two properties, but those two properties we can mix it as a one property. What I mean, here you are taking v1 plus v2 belongs to v for every v1 and v2 in v, and similarly alpha v belongs to v, right? So these two can be combined as a single property. So let me write it here. v1 plus alpha into v2 belongs to v for every v1 comma v2 in v, and for every alpha from the field. Means instead of checking these two conditions separately, instead of checking these two conditions individually, it is enough to check this condition once. That's it. Okay, so let me illustrate with an example. For example, let me take set of all symmetric matrices. Okay, I'm taking symmetric matrices of size 2. So let me assume my set or subspace a 2 by 2 matrix of with real entries such that A transpose equal to A. All right. So this is what definition for symmetric matrix, and I'm taking set of all symmetric matrices here. For example, if you take a symmetric matrix, how will it be? A equal to A, B, and here I should have B, C, right? And you can see that A transpose is same as A here. This is how it looks like. All right. Now I'd like to see whether is this a subspace of M2 or not. M2, I mean set of all 2 by 2 matrices of size with real entries. So now let me do one thing. Let me pick up two elements. Let me assume U1. Instead of writing U1 V, let me use the A and B. Okay. So let me assume that A belongs to U, comma B belongs to U. It means A transpose equal to A and B transpose equal to B. This is what we know. Now we'd like to see whether this U is a subspace or not. Now let us go for this one condition, that is V1 plus alpha into V2, where your V1 is first element and V2 is the second element. So that is A plus alpha into B. Now we need to check whether this belongs to our set U or not. Now how do we check? We have to take transpose of this entire matrix. If you get the same matrix again, then I can say it belongs to U. Otherwise, no. So let me take transpose A plus alpha B whole transpose. So from the properties of transpose, I can rewrite it like this. That is A transpose plus alpha into B whole transpose. Okay. And again, using the properties of transpose, then I'm allowed to take this alpha out. Okay. This is alpha into B transpose. Now we know something about A. We know A transpose is nothing but A. Why? Because A is coming from U plus alpha into this alpha into B transpose is nothing but B. Yeah. So now if you take transpose of this matrix, you end up with the same matrix. Therefore, it is very clear that this A plus alpha B, this is an element of U. That's it. So here vector addition is closed and also the scalar multiplication is also closed. Instead of checking individually, we just checked it with one condition. Right. Yeah, here I should mention that alpha belongs to real numbers. So therefore, the conclusion is that U over R is a subspace of M2 over R with standard addition and scalar multiplication. I'm not defining any new addition or new multiplication. I'm taking the additions and multiplications which were already defined, the standard ones only. Okay, but if we define a new addition, we have to mention here. All right. Now we came to know that to check whether a set is a subspace or not, it is enough to check only one condition. Okay, and moreover, we can write this as an if and only if statement. That is, let P over F be a vector space. Okay, and you know that U is a subset of V. Now U is a subspace of V if and only if you can say U1 plus alpha into U2. This is an element of U for every U1 comma U2 coming from capital U and alpha coming from the field. You can take it as a theorem. So one condition check is enough to check whether it is a subspace or not. That's it. And the next thing. Now you have a vector space V, right? Now you came to know that U is a subspace, all right? And similarly, W is also a subspace. Okay. See here, I'm taking this intersection. Why? Because every subspace will contain zero. Every subspace should contain zero. Okay, that's why if you take any two subspaces of a vector space, definitely zero will be there in their intersection. You may have more than zero. Okay, let me assume there is another subspace. Let me write it as some u2. Okay, so now the question is, if u1 is a subspace of V and u2 is a subspace of V, what can you say about their combinations? I mean, the combination, you can talk about u1 union u2 and u1 intersection u2. All right. So now the question is, let me write it here. Let V over F be a vector space. Okay. And it is given that U over F and W over F, these are subspaces of V. Now the first question, is U union W a subspace of V? And similarly, the second question, U intersection W, a subspace of V. Right. Now to verify these facts, let us take the known examples first. Let us take a vector space and you take their subspaces, the known subspaces, and you think about their union, similarly the intersection. So I'll do one thing. I'll take V equal to the big vector spaces R2. Right. Now the subspaces, R2 itself is a subspace, but it is not good to deal with R2 because R2 union with anything is R2. Okay. So you take a subspace which is smaller than R2, so which is nothing but. Now I'll do one thing. I'll take this x-axis and y-axis. This is x and this is y. Right? X-axis itself is a subspace of R2. All right. So now the one subspace, what I'm taking is set of all x comma 0 such that x belongs to R. All right. So you're taking from R2. Now I'm taking another subspace, that is y-axis 0 comma y in R2 such that y belongs to real numbers. Now how about their union and their intersection? Intersection of x-axis and y-axis is a zero element. That is a subspace. So as of now, for this example, intersection is a subspace. But how about their union? What is the union of x-axis and y-axis? If you observe that it is just the plus symbol. Or in other words, whatever you are seeing here. All right. Now you do one thing. You pick up one element in W and another element in X. U, and you add these two. So when you add these two guys, the resultant will be here. So the resultant will be here. Now it is going away from the union. Are you getting it? What I mean, 1 comma 0 is an element of U union W. Why? Because it is there in U. And similarly, 0 comma 1, it is an element of U union W because it is there in W. Now, but when you add these two, that is 1, 0 plus 0, 1, you'll get 1 comma 1. All right. Now this 1 comma 1, it doesn't belongs to U union W. Why? Because it is neither on the x-axis nor on the y-axis. So therefore, union of two subspaces. In this example, it is not a subspace. But is it true always? Can I say that union of two subspaces is always not a subspace? And let me do one thing. So in this example, union is not, and intersection is a subspace. That is what we found. And now let me work out with one more. Now let me take the vector space as R3. All right. R3 over R only. Now the one subspace U, which is nothing but x-axis. I'd like to take x-axis. X0, 0 in R3 such that x belongs to, sorry. If you say it is an R3, no need to say x belongs to real numbers. Let me write it like this. X0, 0 such that x belongs to real numbers. All right. Now this is clearly a subset of, more of a proper subset of R3. And it is a subspace also. Okay. And W, so I'd like to take this xy plane, that is x comma y comma 0, such that x comma y, they can be any real numbers. Okay. Now this is a subset of R3. Now the question is, how about U union W? Yeah. How about U union W? Can someone respond? You try to see one thing. U is contained in W, right? X-axis and the xy plane. In the xy plane only, there is x-axis. So if you take their union, that will be again xy plane. So if you observe that U union W is W again. And you know W is a subspace. And that is equal to U union W. Therefore, here the conclusion is that U union W is a subspace. Okay. And the second thing, if you look at U intersection W, xy plane intersection with x-axis is nothing but just the x-axis, no? So that is what U. And you know U itself is a subspace. Therefore, U intersection W is a subspace. Subspace of R3. Okay. So in the earlier example, you are taking x and two subspaces, their intersection is only 0 vector. But here, in this example, we started with two subspaces such that one is contained in another. Okay, so for this case, union is a subspace. But for the earlier case, union is not a subspace. So when it comes to intersection, in two cases, it is always a subspace, U intersection W. And of course, we can directly prove that U intersection W is a subspace of a vector space, but U union W need not be a subspace. And you know when this U union W will be a subspace? If one is contained in another, then only it can be a subspace. Otherwise, it is not. Okay. So let me give you the statement here. Right. So U intersection W is always a subspace of V. Okay, that we are going to prove now. But U union W is a subspace of V if and only if U is contained in W or W is contained in U. So in these two cases only, union can be a subspace. In rest of the cases, it is not. But when it comes to intersection, there are no restrictions. Intersection of any two subspaces is a subspace. Okay, so proof is very easy for the first one. Of course, for the second one also easy. You do one thing. We want to prove that U intersection W is a subspace, right? So what do? you start with two elements in the intersection. So let me assume some what to use. Let me use V only. So let me assume that V1 comma V2, these are elements of U intersection W, and alpha is an element of F. Okay, so here, so let me come to the first element. We are saying that V1 is an element of U intersection W, right? Anyway, no need. So you are saying V1 and V2 are elements of this intersection. It means that V1 comma V2, these are elements of U, and also V1 comma V2, these are elements of W. But you know one thing, individually they are subspaces. U is a subspace, W is a subspace. So therefore, V1 plus alpha into V2, this is an element of U. Why? Because U is a subspace. And similarly, V1 plus alpha V2, this is an element of W. Since you can write here, U is a subspace and W is a subspace. All right. Now you can see that this element V1 plus alpha V2, which is present in both sets, it means it is present in the intersection. That is V1 plus alpha V2, it belongs to U intersection W. So if V1 plus alpha V2 is there in this intersection, we can conclude that this U intersection W is a subspace of V. That's it. Over the same field. Okay. So we are done with the first one. All right. Now the second one. So if you observe that one way it is easy, this way it is easy. Why? Because if U is contained in W, U union W is nothing but W. Or the other way, if W is contained in U, U union W is equal to U. Right? Since you know W is a subspace, U is a subspace. So directly you can conclude that their union is also subspace. What I mean individually. If in the first case, if U is contained in W, union is W. Since W is a subspace, therefore union is a subspace. Similarly, the other one. All right. But how about the other way? Okay. So I'll concentrate on the other way only, not this way. Why? Because it is obvious. You can see it. So now we'd like to prove that. So the second thing. So we'd like to prove this way. The other way is obvious. This way is obvious. Okay, I'm leaving it to you as an exercise. U union W is a subspace where U comma W are subspaces. Okay, here it is already provided in the beginning itself. In the hypothesis, you can see U and W are subspaces. All right. So you came to know that U union W is a subspace. Now we'd like to prove either U is contained in W or W is contained in U. Okay. So for that, let me do one thing. Let me take an element in this union. Let V belongs to U union W. This implies V, either it is an element of U or V is an element of W. So if it is in both, well and good, no issue. But if it is strictly, let me assume it in this way. Let me assume V is an element in U and it is not an element of W. Are you getting it? If you want one element to be in their union, it is enough to stay in one set. No need to stay in two sets. Right. So let me assume that V is such an element that V belongs to U, but V doesn't belongs to W. All right. So if V is in U, and what is the advantage? And we know something. We know that alpha V is not there in W. What is it we'd like to prove here? We'd like to prove that either U is contained in W or W is contained in U. This is what we'd like to prove. So I'll do one thing. I'll go by contradiction. Let me assume that this is not true. What I'm assuming is U is not contained in W. This is what I have to prove. But I'm assuming that no, it is not. It is not. So if I take that, I'm going to get some contradiction. So let me have this assumption first. U is not contained in W. Right? If U is not contained in W, then definitely it is possible to find a V in U which is not there in W. Why? Because U is not a subset of W. It is possible. Right? And one more thing also I'm assuming. W is not contained in U also. These are the assumptions we are taking. Let me write those assumptions clearly. Let or assume that U does not contain in W and W does not contain in U. Right. Now, if it is true, then definitely it is possible to find an element let V be an element in U union W such that V belongs to U and V doesn't belongs to W. It is possible to choose such an element. Why? Because U is not totally contained in W. And similarly, let me pick up one more element. Let me name it as V1 and let V2 be an element that is in U union W such that this V2 does not belongs to U, but this V2 belongs to W. This is V1. Okay, so now we picked up one element which is there in U but not in W, and another element which is there in W but not in U. Okay, now our aim is to prove that this assumption is wrong. Once if you prove this assumption is wrong, what must be the correct assumption? The correct assumption is either U is contained in W or W is contained in U. Okay, so let me try to prove this assumption is wrong. So let me take these two elements V1 plus V2. Sorry, this V1 and V2 are coming from this union U union W, and you know one thing, this U union W is a subspace. So when it is a subspace, then definitely V1 plus alpha into V2, it is also an element of U union W. Since you know U is a subspace. Sorry, U union W is a subspace. All right. Now I need to get something wrong here, right? Why? Because I started with the wrong assumption. So what we'll do is we are going to prove that this V1 it also belongs to W. That is what we'll prove. And if you prove that, it means it is wrong. This wrong thing happened because your assumption is wrong. Okay, so that is a strategy here. All right. So now here V1 plus alpha V2, this is an element of union. It means either V1 plus V2, either it belongs to U or V1 plus V2, it is an element of alpha V2, it is an element of W. Okay, so let me go with the first case. Suppose if it belongs to U, right? So if it belongs to U, and you know V1 is an element of U, V1 is an element of U, and V1 plus alpha V2, this is also an element of U, and you know U is a subspace. Therefore, their combination is also an element of U. What is their combination? Their combination is nothing but V1. Let me take this combination: minus V1 plus V1 plus alpha V2. This is an element of U because U is a subspace. Now if you add them, you'll get alpha into V2. Alpha into V2 is an element of U. It means that we are saying if I take alpha equal to 1, it means that V2 belongs to U. This alpha can be any number from the field, right? I'm taking alpha equal to 1. So when alpha is 1, that implies V2 is an element of U. Alpha 1 కాకపోయినా చెప్పొచ్చండి. You can multiply with 1 by alpha so that you'll get V2. But how did we choose this V2? We have chosen this V2 in such a way that V2 doesn't belongs to U and V2 belongs to W. But what is it you got here? V2 is an element of W. ఈ V2ని మనం యూలో లేకుండా చూస్ చేసుకున్నాం అండి, కానీ ఇక్కడ మనకు వచ్చింది ఏంటి? ఈ V2 అనేది యూలో ఉంటుందని వచ్చింది. That means we got wrong thing, right? So why did we get this wrong thing? Because we started with a wrong assumption. So this is our wrong assumption. So let me write that this is a contradiction. This is contradiction to the fact that V2 does not belongs to U. Okay. So therefore, our assumption is wrong. Our assumption is wrong. What is our assumption? U doesn't contain in W. Similarly, W doesn't contain in U. So that assumption is wrong. So what must be the correct one? So the correct one is either U is contained in W or W is contained in U. So this must be true. Okay. And you may ask one thing, sir, you have taken only one side. What about the other side? Okay, let us try the other side also. If V1 plus V2 is an element of W, then you know V2 is an element of W. And one more thing you know about V2. V2 doesn't belongs to U. That is how we have chosen, no? All right. But no need to mention here. Now V2 is an element of W, and similarly V1 plus V2. ఇక్కడ alpha place లో direct గా 1 తీసుకుంటున్నాము. Okay. V1 plus V2, this is an element of W. Now what do? You just multiply the first expression with minus 1. So minus 1 into V2 plus V1 plus V2. Since W is a subspace, their sum belongs to W, right? Now you can cancel and finally you end up with V1. Now V1 belongs to W. But how did we choose this V1? We have chosen this V1 in such a way that V1 is an element of U, but it is not an element of W. But you end up with this guy. V1 is an element of W. So this is a contradiction. Okay. So however you take, so we are always end up with the contradiction because of wrong assumption. So our assumption is U doesn't contain in W, W doesn't contain in U. That is the wrong assumption. So therefore, this must be correct. Right? So this must be the correct assumption. It means that if union is a subspace, then definitely one subspace is contained in another. So therefore the conclusion is this. Therefore, if U union W is a subspace, then either U is contained in W or W is contained in U. That's it. Okay. So union of two subspaces need not be a subspace, but intersection of two subspaces is always a subspace. And union is a subspace if and only if one is contained in another. Okay, so I'm going to end this class with just one more topic, that is linear combination. Okay, so you have a vector space over some field, right? So you have some set and you know some elements in it. Okay, now I would like to combine these elements. How do you combine? It's like you can add them because you know how to add two vectors here, and you can multiply with a scalar. That is scalar multiplication, alpha into v. Okay, so now if you take, let's say v1, v2, v3. So let me start with three elements. Okay, now if you write alpha 1 into v1 plus alpha 2 into v2 plus alpha 3 into v3, where these alpha i's are coming from the field. Okay, so I'm multiplying each vector with a scalar and I'm adding those results. And this is what we call linear combination of these three vectors. Okay, so let me write it. Linear combination of so these vectors v1, v2, v3 is given by this alpha 1 into v1 plus alpha 2 into v2 plus alpha 3 into v3. This is what we call linear combination. Okay, whereas if you take this these vectors as a set, let me assume some set S is equal to, instead of using S, let me use some A. Okay, so now A equal to, this is the set which contains v1, v2, v3. Just there are three vectors in it. Okay, now so if you consider set of all linear combinations of these elements, so try to understand one thing here. You have written only one combination. Okay, so now I would like to consider all possible combinations. What I mean, for example, you assume that v1 is 1 comma 2, okay, and v2 is 3 comma 4. What about their linear combination? You can take alpha to be some element. Let me take alpha 1 equal to 3 and alpha 2 equal to minus 1. So now the linear combination is nothing but 3 into 1 comma 2 plus minus 1 into 3 comma 4. So this is the linear combination with specific alpha 1 and alpha 2. So suppose if you keep this alpha 1 and alpha 2 arbitrary, alpha 1, alpha 2, right, where alpha 1 comma alpha 2 belongs to the real number set, then this one represents possible combinations. Okay, or in other words, it represents all combinations of these two vectors, right? And this is what we call linear span. Okay, let me mention that set here. So we are going to denote that set like this: linear span of A. simply we write it as ls of A. So let me write what it means. Linear span of A, which is nothing but set of all linear combinations of these elements. That is alpha 1 V1 plus alpha 2 V2 plus alpha 3 V3, such that alpha I is coming from the field where I is equal to 1, 2, 3. That's it. Okay. And there is a reason why we call this as a linear span. If you look the geometry, it looks very beautiful. So I hope you understand what is a linear combination. Just multiplying with a scalar and then adding those resultant vectors. That is the linear combination. Okay. Now I have one question. So my set here is the set which contains two elements, 1 comma 0 and 0 comma 1. All right. Now can you tell me what is the linear span of S? Let me do one thing. Let me start with the singleton set first, and later I'll go to the two element set. What is the linear span of S here? Your set contains only one element. Can someone respond? All right, let me help you. So the question is, what is the linear span of S? Now, as per the definition, so the linear span of S is nothing but set of all linear combinations of those elements. There is only one element, so I can simply write alpha into 1 comma 0 such that alpha belongs to real numbers. Okay. So if I say this, you should assume that our vector space is R2 over R. Why? Because it is clearly subset of R2. Okay. So now this is nothing but set of all alpha comma 0 such that alpha belongs to real numbers. Geometrically, what does this set represents? What is it? X-axis. Good. So this represents x-axis. It is nothing but the x-axis. All right. Now I can say that this element 1 comma 0 spans the x-axis. It means every element in the x-axis can be written with the help of this one element 1 comma 0. అంటే నాకు జస్ట్ మీరు నాకు 1 comma 0 ఇవ్వండి, నేను x-axisలో ఏ ఎలిమెంట్ దగ్గరికైనా ట్రావెల్ చేయగలను. ఎట్లా ట్రావెల్ చేస్తా? ఆల్ఫాతో మల్టిప్లై చేస్తాను, ఎక్కడికి కావాలంటే అక్కడికి వెళ్తా x-axis పైన. అంటే ఫర్ ఎగ్జాంపుల్ ఇఫ్ యూ వాంట్ టు రీచ్ ద లొకేషన్ √2 comma 0, ఏముంది సార్ నాకు √2 ఇవ్వండి, మల్టిప్లై చేస్తా, అక్కడికి వెళ్ళి కూర్చుంటా. ఆల్ రైట్. Now the beautiful thing is this element 1 comma 0 spans the x-axis. తెలుగులో స్పానిక్ మీనింగ్ ఏంటంటే అల్లడం అంటారుగా. Anyway, you may not appreciate because it is just a line. Now let us see something interesting here. So the question 2. So answer to this earlier question is linear span of S is an x-axis. Right. So now the question number 2. Let me take S equal to 1 comma 0 and 0 comma 1. Now what is the linear span of this? What is it? Y equal to X line. Think. ఒకటి చూడండి, మీరు కాంబినేషన్ తీసుకునేటప్పుడు ఆ రెండు ఆల్ఫాస్ ఈక్వల్ అవనవసరం లేదు. ఈక్వల్ అయ్యేటట్టు తీసుకోవచ్చు, అది ఫైన్. కానీ ఖచ్చితంగా ఈక్వల్ అయితే కానవసరం లేదు. ఇప్పుడు ఫర్ ఎగ్జాంపుల్ ఇక్కడ నేను ఆల్ఫా 1 ఆల్ఫా 2 తీసుకుంటాను కదమ్మా. ఈ ఆల్ఫా 1 ఆల్ఫా 2 అవి ఈక్వల్ అవ్వచ్చు, అవ్వకపోవచ్చు. మీరు ఎట్లయినా తీసుకోవచ్చు. అంటే ఒకటైతే చెప్పగలను, x=y లైన్ మీద ఆ లైన్ పైన ఏ పాయింట్స్ అనేది వీటితో అయితే జనరేట్ చేయొచ్చు, నో ప్రాబ్లం. అంటే అది ఒక్కటేనా, x=y లైన్ ఒక్కటేనా, ఇంకేదన్నా ఉంటుందా? Yeah, here is a entire coordinate axis. Why again you used axis? Okay, entire coordinate axis. Does it mean the entire R2 or just the plus symbol? Okay, if it is entire xy plane, fine. But if you think it is just plus symbol, it is not correct. Plus symbol, it cannot be a vector space, first of all. Actually linear span vector space span isna cheppaledu kada. Let me do not use that. So first let me look at the linear combination here, linear span. So linear span of S is nothing but set of all alpha 1 into 1 comma 0 plus alpha 2 into 0 comma 1 such that alpha 1 comma alpha 2 are coming from real numbers. అమ్మ నేను ఆల్ఫా తీసుకున్నాను, మీరు ఆల్ఫానే తీసుకోవాలని లేదు, మీరు లాంబ్డా తీసుకోవచ్చు, ఎక్స్ తీసుకోవచ్చు. అంటే యూ షుడ్ అండర్స్టాండ్ దట్ దోస్ ఆర్ రియల్ నెంబర్స్ అంతే. మీరు అక్కడ నొటేషన్ వైజ్ ఏదైనా యూజ్ చేయొచ్చు, నో ప్రాబ్లం, రైట్? సో ఇఫ్ యూ మల్టిప్లై యూ విల్ గెట్ alpha 1 comma 0 plus 0 comma alpha 2 such that alpha 1 comma alpha 2 belongs to R. Now this equal to alpha 1 comma alpha 2 such that alpha 1 alpha 2 are coming from real numbers. Now you may not recognize if you see it this way, so let me change it to this form. Alpha 1 plus x తీసుకుంటున్నా అండి, alpha 2 plus y తీసుకుంటున్నా. Okay, so this is nothing but set of all x comma y such that xy belongs to real numbers. And what is this set actually? What is this set? This set is entire R2. I can give you any element in R2 just with the help of two elements, that is 1 comma 0 and 0 comma 1. Okay, suppose if you want 10 comma 15, ఫస్ట్ ఎలిమెంట్ ని 10 తో మల్టిప్లై చేయండి, సెకండ్ ఎలిమెంట్ ని 15 తో మల్టిప్లై చేయండి, రెండింటిని యాడ్ చేయండి, you will get 10 comma 15. Okay, and of course this has a geometrical meaning also. It is not just some additions or multiplications. ఇప్పుడు 1 comma 0 ఇక్కడ ఉంది సార్, 1 comma 0 is this and 0 comma 1 is here. Let me assume this is 1 comma 0 and the other one is 0 comma 1, right? సో మీకు ఇప్పుడు ఇక్కడ కావాల్సిన ఎలిమెంట్, లెట్ మీ టేక్ సమ్ 5 comma 2 అని తీసుకుంటాను సార్. 5 comma 2 ఈ రెండింటి నుంచి ఎట్లా ఆబ్టైన్ చేస్తారు? అలాంగ్ ఎక్స్ యాక్సిస్ డైరెక్షన్ లో 5 యూనిట్స్ వాక్ చేయండి, అంటే 5 into 1 comma 0. నెక్స్ట్ ఏం చేస్తారు? వై యాక్సిస్ డైరెక్షన్ లో, అంటే ఇది వాక్ చేసిన తర్వాత వై యాక్సిస్ డైరెక్షన్ లో 2 యూనిట్స్ వాక్ చేయండి, అంటే ప్లస్ 2 times of 0 comma 1. So that is how you can end up with 5 comma 2. Okay, so if you just give me these two directions in R2, I can move to any point in the plane. Just ఈ రెండు డైరెక్షన్స్ మాత్రమే యూజ్ చేసి నేను ఏ పాయింట్ నైనా రీచ్ అవ్వగలనండి, రైట్? ఇంకొకరు వేరే డౌట్ రావచ్చు, సార్ మరి ఇప్పుడు నేను ఇక్కడ పాయింట్ తీసుకుంటే మరి ఎట్లా రీచ్ అవుతారు? లెట్ మీ అస్యూమ్ దిస్ పాయింట్ ఈస్ -1 comma -3, -1 comma -3. Then how do you obtain -1 -3 here? Can someone respond? All right, so we can reach to -1 -3, just multiply the first element with -1, second element with -3 here. అంటే ఈ డైరెక్షన్ అంటే మీరు ఆపోజిట్ కూడా వెళ్ళొచ్చు ఇట్లా. సో అలాంగ్ దిస్ నెగటివ్ ఎక్స్ యాక్సిస్ డైరెక్షన్ యూ ట్రావెల్ 1 యూనిట్. అంటే దాన్నే మనకు కావాలంటే -1 యూనిట్ అంటాం, అంటే ఆపోజిట్ వేలో ట్రావెల్ చేస్తాం. సిమిలర్లీ -3 యూనిట్స్ హియర్, ఐ మీన్ 3 యూనిట్స్ in the opposite direction of y, so that you will reach to this point. Okay, so now it is beautiful. Only 2 elements are giving you entire R2. Just 2 elements are giving you the entire R2. Okay, so having the big plane, it is same as having these 2 vectors. Or having these 2 vectors, it is same as having the big plane. Big plane unte 2 vectors untayi, అది matter కాదు. But having these 2 vectors, it is same as having the entire plane. No need to carry the entire plane. Just I'll take these 2 vehicles. Okay, so now wherever I want to go, I'll just take help of these vehicles and I'll go. That's it. All right. So similarly, I'll give you a few more questions. You think about them. Question number 3, s is equal to 1 comma -1 and 1 comma 1. What could be the linear span of these 2 elements? Q4 s equal to 1 0 0 0 1 0, right, 0 0 1. What will be the linear span of these? And question 5, 1 0 1 0 1 1, right, and next 1 1 2. So think about linear span of these guys, and not only this, I'll give you a few more. Set of all polynomials, right? So let me give an example from that. You find the linear combination of 1 minus x 1 plus x squared. Okay, and this is a subset of P2. P2, I mean set of all polynomials of degree less than or equal to 2. All right, so these are the exercises. You please do it.